Hey, welcome. Episode 47 of the IoT Happy Hour here at Balena. Welcome, everyone. Hope everyone is having a good week. We are back after, 2 weeks, I think we missed, right?
2 weeks off. Yeah, we had some internal summits and a hack week. So we had some stuff going on over here, but it's good to be back.
Absolutely, I needed to be back to see what we can do. And we are coming back with rock and roll today, right?
Rock and roll?
We have a rock star today here with us.
You're too kind.
We sure do. And I see, although our badge is covering it, actually, let's see if I can just switch you right over to here. There is the infamous LED alerter. If anyone still has the URL, I don't know, Alan, is that thing still active?
It should be actually the same URL for a year now. I think.
Wow.
I think it's still working.
It's been a while since we've seen it. But
you're old.
I don't know. I don't have the URL. It was on an old laptop now at this point, but if anyone has it, feel free to give it a buzz.
George JR, he has it on his bookmark.
You know he has it bookmarked.
Nice.
All right.
Before getting into the topic of today for building applications with the new balenaBlocks, we should mention that we are hiring. We opened some new positions, right?
I believe you are correct. In fact, we've talked about one or two of them previously, which is our front-end engineer and security engineer. I believe we have talked about previously, but I see a new one on there, Mark. What's that new one on there?
Yeah, we need an engineer for Etcher, Balena Etcher. If you never flash your SD card with Etcher, we need an engineer there who can help us to make Etcher better and bigger.
Awesome.
So I would say go to this URL. We can put it on the chat, right?
Yep, I'll do that right now.
Or you can go to balena.io on the bottom, on the footer. There is a link for jobs, so you can find all the descriptions there. And we also have the fourth, the design your own job, right, as well.
That is always there. I'm looking at it. It's funny because it says that it was posted about 5 years ago. So it is in fact legitimate. There's no need. Maybe we could update the date to say that it was posted, a month ago or something. I don't know. It was posted 5 years ago and it's still valid. So if there's something you have in mind to bring to Balena, by all means, fill that one out. But yep. Couple of other more specific openings there as well.
Cool. So, by the way, welcome, Alan, to the IoT Happy Hour. Long time we don't see you.
Yeah, thank you. It's good to be here. It has been probably about 5-6 weeks, I think, since my last appearance. So.
Yeah.
What have you been busy with?
Oh, lots of stuff. Mainly the stuff you'll see today, I guess.
Awesome. Give us a just quick 1-minute overview so folks know what we're about to get into. What's on the agenda for the day?
Yeah, absolutely. Well, we're going to look at 2 different blocks, and I think we talked about blocks in the past. They're little bits of functionality that you can build other things with and connect them together. And we have 2 new ones that we're introducing today. One is called the sensor block, which basically allows you to just connect different types of sensors to a Pi and get the data out of them really quick and easy. And the other one is similar as a pulse block, which allows you to read a incoming pulse and get the data out of that too. And then we can feed it to graphing or dashboards or some other things that we put together here.
Nice.
Basically.
Yeah, interesting. Very cool. I'll be excited to see that pulse one. I'm not too sure what that could entail, but I have some ideas in mind. So, all right. What do you think?
Rahul here. Hello,
Rahul. Welcome.
Hey, Rahul.
He's staying up late to watch the broadcast. All right. Should we dive into what's on your desk? Let me
Yeah, I miss what's on your desk. Yeah, sure.
Yeah, it's been a few weeks.
Last episode we missed the music, but so I don't know if Alan May wants to sing the "What's on Your Desk" jingle.
I think that we need to use tradition and hear our one from Chris.
Okay, we can go virtual.
I think
That's legit. That's
yeah.
What's on your desk?
Always a classic.
I couldn't do that justice, so I'm glad we used
no
that.
no one can. I mean, I've even thought about, maybe I could record one. No, there's no chance. How am I going to compete with that? All right. So who wants to go first? Mark, I think you may have said you were skipping this round, and Alan
Everything
took
that I
your
have
spot.
on my desk, I already show it on what's on your desk.
Okay. So I'll go first. I'll go very, very quickly because Alan's got some goodies over there. So
let's make it short.
Yeah. So let's
We always
do
promise.
mine.
Give me a sec that I
There we go. I have finally gotten a hold of a Raspberry Pi Pico. Now, this is their first entry into a microcontroller board. So that right there is their own RP2040 MCU. It's based on a dual-core Cortex M0. I've gotten only so far as blinking the LED, but I mean, as any good project, that's that's pretty much what you want to focus on. So now here is
that's very small.
Well, that's why I wanted to do this.
Okay.
So apologies for blurry cam being a little unstable here as I'm trying to move him. But yeah, it's tiny. It's the smallest little thing. I mean, even here's a BME 680 that we'll, talk about later. But here's a Pi Compute module right here. And here's, of course, your standard Pi 4. So it is a tiny little thing. Absolutely. So there you have it. Pi Pico.
This is the same Arduino MKR form factor, or do you know that?
I don't know off the top of my head.
You don't have any.
We'll have to look it up. I'm not sure if iShot JR is
you
in
have a
or not.
banana.
I do not have a banana on my desk. I should have gotten a banana. You're right. But yeah, I mean, it is a tiny little thing. It's hard to even, kind of on screen show, but it is small.
Yeah, looking forward to seeing.
Yeah.
What can you do?
Very neat. That's on my list to get one of those. Can't wait.
Yeah, $4, pretty cheap.
Yeah, nice.
All right.
What's on your desk?
Okay. Well, let me start with the little bit more mundane items that I have here.
Wait a sec.
Let's make him larger.
Yeah,
Yep, there we go.
I build a lot of projects, and
We know.
I believe that every project should have an LCD screen on it.
Wait a minute. Hold that up closer.
So
I need to do a
have a few different
closer
ones here.
investigation. Okay, perfect.
But these are the two that you use for the pumpkin, right?
This is the one that I used for the pumpkin. This is a slightly larger version, and I'm using them, pretty much anywhere. These are the ones you can get at Adafruit.
These are Adafruits.
And they do have a micro SD card holder on the back. And yes, I have kept the film on, and I plan to keep the film.
Of course.
So,
awesome.
yeah, like I said, I just love these displays, and I think they really go with anything. So
Yep.
it's just great to have.
Super cool.
The other item here, I wanted to show you this really new, cool, advanced digital camera that I got. Super high res.
Oh, is it one of those?
It's this one right here. Okay.
Wow.
This is the
man.
Sony Mavica, and
What?
this one it's a little thick. It is a 1 megapixel. It has an entire megapixel. And
Okay.
It
So,
actually works.
wow.
You can turn it on.
Wait, what?
And this works. It's a really cool.
Now, how many gigabytes of storage are internal on that unit?
Okay, well, it has this advanced storage system that I'll have to show you here.
Okay. Okay.
Oh, nice.
It
Oh,
uses-
no way, no way.
Goodness.
Uses the,
oh my
floppy
goodness.
disk. So let's give it a try, actually. But I wanted to give you some stats on this.
No, wait a
boy.
minute. Wait a minute. The lens cap is on. You're not going to get anything.
That's a good point. Let's take the lens back up.
Get that lens cap. Yeah. Well, it's to keep the film on. I understand.
Exactly.
Yeah.
But some stats on this camera. It's from 1998, so we're talking almost a quarter century old.
Oh my
this camera.
goodness.
It's 1 megapixel, and its original price in 1998 was $899.
Oh my
for this 1
goodness.
megapixel.
And then
in
with
today's-
inflation, yeah.
With inflation, this is a $1,400 camera. And the best part about it for me is that how much
Wait,
did I pay for it?
Wait a
Let
minute.
me
What
get
is that
the-
green price tag on there?
No.
$3.
I
Wait.
paid $3 for this
What?
at a it's like a flea market. When I saw it, I'm like, I have to get this.
Yeah, absolutely. Now, did that
Now-
come? Did the $3 include the floppy disk?
Yeah, that's the best part. I mean,
Ah.
how can you pass up a deal like that? I mean, really. So
Oh my!
let's take a quick picture. This is almost a selfie since I'm taking a picture of this.
Wait a sec.
Yeah.
Okay, everybody, smile. Okay. Recording. Now that was really fast. It recorded that really fast.
Recording what? Like saving the image?
Yeah, on
Saving.
the
Yeah, it said
property.
recording. If you look, it has something funny here. It says, let me see if I can.
Wait a sec. I will zoom.
Yeah.
I
Hold
will-
on.
It says that it has
Oh,
quick access FD drive, whatever that means. But
Super.
the floppy drive.
but the floppy, it only churned for about 3 seconds, which is unusual for a floppy. They're usually pretty they're pretty slow, so they usually churn for like 10 minutes. But that's not all here. I wanted to.
There's more?
Yeah, how could we take this and turn this into something that is really IoT related? So I have
way.
here.
No.
This is probably the first Balena device out of many that we have that is connected. Trying to get in front of the camera. here.
Left. Yeah, left.
To a,
You're
floppy
right.
drive.
You're right. Go
I think
right.
we have
Go right.
many. What like that?
Up.
Yeah, we can
No.
see it.
Okay. So I believe this is the first.
No, we. Oh my
Okay.
God,
No.
So
So
this
you have a RPi floppy. Yes, I shot. JR's got it. It's an RPi floppy drive reader.
It's a Balena RPi
Oh
floppy
my
drive reader. So
Goodness.
let's give it a shot here.
No, live. We didn't say any prayers. No.
Oh my God.
Let's hope this works. Okay, so
Oh, this
I
is.
want to switch to my screen share here.
Sure, yeah.
Screen share is on. Hold
Oops.
on. Make that
Yes.
larger. Okay. Yep. Mark's
Okay.
got it. Perfect.
I believe it's all set. So if we do this, now this is okay. Don't worry. I need to.
Well, I mean, it's a red
Massage.
error. I'm worried.
I need to massage this slightly.
Oh, massage.
Yes.
Wait a minute. Now, what if you had to buy more storage? Can you purchase floppy drives?
I believe, yeah, that you can.
They still make them?
Let's see. Did I get this right? Oh, it'd be nice if this worked. Not quite. Let's try one.
I'm not expecting this to work. There is no way. There's no way that this is gonna.
Oh, let's see. Is it running? Looks good. It should.
Device name is on point. The device name is Hello 1998.
Let's see if I.
What is happening right now?
Now, let me try one other thing here. It should work, but let's switch
What?
to 1998.
What? Yeah,
Let's
hold on a
try.
minute. Is that an AOL free trial
With Napster?
Maybe we should sign up.
and Real Player?
Listen to Real Player G2.
Oh,
But
I'm in.
Internet Explorer.
let's try.
Wait,
Let's try
what version
Internet
is this?
Explorer 5.
This is.
And let's just. Oh, it's saying it's not found. That's a shame. It was working, and this actually does work. Maybe I'll reboot it. We can try it again later.
I don't know if
Am I missing something here?
Missing something. Yeah,
It's a
25 years. You're missing. What Windows version was that?
That was Windows 98 second edition.
Oh, not the first edition. That one was junk.
No, we need the second edition. But yeah, this does actually work. I'm just
for anyone just joining now, you are.
I don't want to dwell on this because obviously this is not why we're here. But
yeah, we don't want to spend too much time on this. But
perhaps you'll let me come back to a future IoT Happy Hour just to redo the what's on my desk so we can look at the.
You can bring this back anytime.
Absolutely.
So it's a web server, and you can see the.
Did you get this error here? I know that's typical.
Is it trying to get? Maybe that my mount is off. You have to.
Do an ls on the /dev and see what it's storing.
I could do that, but I don't. Again, I don't want to. Let's see.
Yeah, let's just check it real quick. Is it in the Nginx?
Let's just retype that mount point in.
So for people who join now,
you guys.
Alan just purchased a new camera. Well, a 1998 Sony camera,
a
1
new camera.
megapixel, for $3 that stores all the pictures on a floppy disk. So he just made a Raspberry Pi 3, I guess, with an external floppy disk unit, and he's trying to access to the picture he took. But he didn't make
on a floppy
praise to the gods.
No.
That's weird.
Are you in the right container?
Yeah. This was all set. I didn't even turn this thing off since the last time it was working. All right. Well, we tried.
That's okay.
That was a good one.
I'm in shock here.
Respect.
Yeah.
We'll try it again another time. But anyway.
Let's try. I'm sure that we will have more time during the episode of today, right?
Yeah, we can try it again. I'm not sure. Did I misspell? Oh, you know what? It's mount, not MNT.
So, it is mount. That's true.
Quick.
Oops, yeah.
It is already
mounted. Dev SDA.
Interesting.
Yeah.
Well, let's try it one more time on the URL here. Let's go back to 1998.
Okay, let's travel back in time once again.
Oh, there we go.
Oh, no. What happened?
Whatever it was, trying to run a web server off of a floppy is really kind of an iffy thing, but let's...
Yeah, maybe it just needed more time.
Oh, there we go.
Oh, nice.
So
unbelievable.
We are in 1998 looking at in Internet Explorer 5, looking at a Raspberry Pi 3 with a floppy drive, with a floppy from 1998 and digital picture from that camera.
Look at that resolution. Wow.
That's a whole megapixel there, David. So
that's an entire megapixel, yeah.
That's $1,400 worth of 1 megapixel. So
I can't believe it.
Incredible. You give the URL out so people can access my floppy from around the world.
Yeah, good idea.
That should work out really well.
Yeah, nothing could go wrong with that plan.
Anyway, thank you.
All right. Well,
that was super amazing, Alan. Congratulations.
Stop, Alan. Stop. The internet connected floppy drive connected to Balena Cloud. All right. Well, that was amazing, but I suspect we should probably take a look at some blocks.
Yes.
Yep.
All right. So should we start with the sensor block? Okay.
You tell us where the best
Yeah, tell
starting
us.
point is. Let me get your screen back on.
Sure.
Add that and that, and there we go. All right.
So, yeah, the sensor block is in the balenaBlocks repo with the other blocks. And as it says here, it auto detects connected I2C sensors and then publishes the data from them on HTTP or MQTT. And when you think about that, it means that it works really well with some of our other blocks like the connector and the dashboard. So theoretically, you should be able to just put all these together and map out or graph on a dashboard the data that comes out of the sensor block. One thing to mention is we built this block using industrial I/O, and IIO is a Linux industrial I/O subsystem, basically a kernel subsystem. It uses the drivers that are already on the kernel for these sensors, so you don't have to load any drivers. That's for the ones that are supported, and you don't have to even really think about it. If the sensor is supported, connect it and go. That's it. And we have here a list of the sensors, and we'll go through this list a little later. But just to show, we probably have 10 or 12 sensors on here to begin with that are compatible. And
interesting that you don't need a driver.
Well, you need a driver.
It's built. Yeah.
Yeah.
Or not. You don't have to mess with the drivers.
Exactly. And there's a way here, I won't go into everything, but there's a way here to test to see if your driver is supported and how well it's supported. And the thing about these drivers is there's probably drivers for almost all the sensors, but it's kind of up to the OS how many it wants to include. So we're talking about Balena OS, and there's a handful in there now. And in the future, there's ways that maybe we can include more, but for now, this is the list of what's in there.
All right. Real quickly, I do need to grab this question from iShot JR. He's very concerned for his friend who thinks that the buzzer URL might have changed.
All right. Well,
to be clear, iShot JR is not concerned. The friend is.
I appreciate that. Well, let's just check it really quickly here and make sure it's still online. This will only take about 10 minutes to scroll down to the actual.
Exactly.
Oh, no. Look at this.
Oh.
3 days ago. I think we need to
it's offline.
do a little power bump here.
All right. Give it a power cycle. Yep.
Yeah.
Okay. Give it about 3 or 4 minutes. It should be.
All right.
So yeah, getting back to this. I think that's the main overview. I don't know if there's any questions. I thought what we would do is just quickly use this block to build a little project.
Sounds good to me.
So you mean that you can get one of these sensors, a Pi, and just with blocks, create an application that automatically gets the data from the sensor, for example, a BME 680, and send HTTP or MQTT requests to somewhere else, to the connector block, for example, or something like that?
Right, without even thinking about the driver, as long as it's in the list that we have.
Automatically.
It should work. You don't have to set I2C addresses. The only time you'd have to set an I2C address is if you have 2 sensors that are trying to use the same address. Then you would have to adjust that. And that's just usually a jumper or hardware.
I want to see that running. Show us how to do it.
Yeah, so let's do that. And that's also documented at the bottom of this repo here. That's basically this. So it's just a Docker compose. There's no other software or files that are necessary. You can do this all with the Docker compose using existing blocks. And if anyone has seen BalenaSense, which is one of our great projects, it's basically now you could build something like BalenaSense using just blocks. And in fact, we plan to update BalenaSense in the near future to just use blocks. But for now, we can show this as a working kind of proof of concept. So I thought we would just, let's just go through this and build it really quickly. So I started the Docker Compose just so we don't have to start completely from scratch.
Well, yeah, there's only 4 lines. That's not really okay.
Well,
I was expecting the full copy paste.
Well, I mean, all right, let's just talk about the things that we need. First of all, we need a sensor block, right? So let's put that in there. So the sensor block is the beginning of it, and again, it's just pulling it from from the Docker Hub. I think
It works.
It still works.
Yeah, well, that's just the startup sound. Let me move it back here so it's visible. Okay. So again, we're not using any other files besides Docker Compose, but we do need to make sure there's certain settings on each one of these. So the sensor needs to be privileged, and it needs a couple of other labels here in order to be able to, sorry, now I'm getting distracted by the beeper. It needs a few other settings here to be able to work for the IIO subsystem to be able to access the kernel. So that's what this is about. There we go.
Now
So
we're back online, says my friend. All right. Kill it. Turn it off.
Yes. Power it off.
All right.
So the next thing that we need is the connector. That's another one of our blocks that, if we go back, we add connector in.
Okay.
Fix this. So connector is going to find the data that's being published by the sensor, and it's going to kind of direct that to where it needs to go. In this case, we need to direct that into a database. So we're going to just use the stock influx DB. So we will add that. So it's going from sensor to connector to influx. I feel like I'm missing, oh yeah, of course. Now how do we look at what we have done? And that would be through the dashboard block. So let's add that. And the dashboard is basically Grafana. So with some added features that we put in to make it, as we say, opinionated. So all of these things will work together to bring the sensor data through the connector into influx and then viewable in the dashboard. And we don't have to do any other settings, device variables, labels. This is it. And we're basically, if you look, we're just pulling images. There's no build going on here.
Yep.
So let's save it and let's push it. So it
Quick
is.
shout out while you're doing that push that Anuj is saying he really enjoys that your editor of choice is gedit, which is also my favorite.
Yeah, I like to keep it simple. So I just want to make sure I'm pushing to the correct repo. This is online, HH47 sensor. So let's do that. Hopefully I didn't like mess up this Docker Compose because I just pasted it in piece by piece, but it looks like it doesn't like that. Data should not have additional properties. So I pasted it in piece by piece, but to make it actually work, I'm just going to grab the whole thing. I obviously edited it poorly.
You don't have the services part, Alan.
Okay.
Well, but yeah, just paste everything.
Oh yeah, services.
Well, so just to be safe, let's just do that.
Then we,
Yeah.
So that's the same thing. You saw me build it.
Yeah, you literally only
piece by
forgot
piece.
that one line.
So
whoops.
Oh, volumes.
Data volumes.
I think I'm missing the top.
Yeah, you
When I
missed
copied this, I missed.
version 2.
I'm not used to working in such a
It's a high pressure environment.
No, it's a low resolution. I made my resolution really low for this screen share, so I'm like missing tops and bottoms of things. If I need an excuse for not being able to push something with 2 tries, so sorry about that. Anyway, so this is looking good now. We're going to push it to this repo right. Oh no, that's Pulse. This is sensor. So we're going to push it here. This is just sitting here waiting. And if you want to switch to the desktop camera here, I will show the target of where this is going.
May need to switch it up. Yep, there we go.
There you go. So
all right.
It's a Pi 3B, and we have an I2C connector here. And then this is a BME 680 sensor. And you see this, I have this 4-way kind of splitter here. Let me see if I can get a closer view of that. I have another one here I can hold up to the camera.
Because you always buy 2 of everything.
I do buy 2 of everything.
I do as well. I understand.
Yeah.
So I believe these connectors are called Stemma QT.
It's a little blurry. It's blurry cam. It's like mine.
I put it on my top camera.
Wait a second. No. Wait a second.
Here we go. I know I'm jumping around a lot. Sorry.
Yeah, it's okay.
That's a little easier to see.
Is that the same as the quick? Is that the quick connector from SparkFun?
I believe it is. I think there's a few different names.
Yeah.
And so this makes it easy if you're using I2C to connect multiple devices, because I2C is a bus, right? So you could theoretically connect many devices, like 4 here, but really you can only get 3 because one side has to go to the
board. Yeah.
To the board. So in addition to that, they also make these cool little cables. So I have one here. So this
I had some of these on my desk at one point, and I'm looking around, and now they're not here.
This is the cable. Yeah. So this has one on each end. So one end would go in here, and then the other end would go into a sensor that has this connector on it.
There it goes. Yep.
So, and these have 2, so they pass through.
Yeah, I had these. Where are they?
This is going. Oh, well, it says it uploaded it already. That's fast. That's good. We won't complain about that. But before we switch back to that, I just wanted to show, some more of the sensors. Some of the sensors that you get will not have that connector and just have the, the headers. So you would need to have a different kind of connector for that. And they do make those.
Did that have the pins pre-soldered though? Were you able to just attach the wires to it, or do you have to do the soldering for it?
For that one, I had to solder the headers in, but I think they're available different ways. Like if you look at this one, it has those connectors on either end, and then these headers that you can just connect with wire. So there's really, there's a lot of different ways you can connect all these together, which makes it really nice and easy to use. So I think
various vendors as well, I would imagine.
Yeah, I think they've standardized it. It might be the quick connector, but I also remember Adafruit calling it something like Stemma QT, I believe. Check that.
I'll Google it.
Yeah.
Let's find out.
But if we go back to the screen share, I believe that it's
got it, Mark.
Yep. Yeah.
Thank you. In record time. So it built all these services. And if we go back to here, it is updating. And it's going rather quickly.
Your devices are called birds, or because the other one was a blackbird.
I know. I almost never rename these except for the Floppy one, because it had to have something old.
It's all the bird.
It's a bird motif, maybe somehow tied in with sensors. I don't know.
I'm lucky that the day that we were catching birds with machine learning algorithm, David, we didn't get any dead bird or.
Yeah, got lucky.
All right. So we had the 4 containers here.
4
the
containers.
sensor.
So yeah, sensor to connector to influx to dashboard, and then
And
the
the
dashboard.
dashboard.
Dashboard should automatically find the new fields that the sensor is producing, and then we should be able to go to the public URL here and see all the data in Grafana. So what else? I guess, for a moment we can talk about, while we're waiting for this to download. And
One last
it's
container
almost there.
coming down.
But we could talk about these sensors for one more minute. And see
Yeah,
the
so let's
list
take a look at that list there. Yeah.
So I've tested a number of the sensors on this list. These are the drivers that are included in Balena OS. So at least for the Pi. Now that can vary. And as it says in this README, you should always try with the modinfo command to see if your sensor is supported. There's a list of them here at this link. So you can find the name of the sensor and then test it. But as far as I know, all of these should be included. But then again, it doesn't always mean that they are actually working. So you can see that I've tested some that just don't work at this point. And I think this is kind of going to be a work in progress to find out why some of these aren't working out of the box and get them working. But still a pretty good variety of ones that do work. And like this one only works partially for some reason, but
PHT.
We have a question, Alan, from Andrew. He's asking, what happens if you connect an unsupported sensor?
Does it try its best?
Does it try its best? That's a good question. I think it will try its best, but you will get a message saying no supported sensor found. That's what would happen if you tried that, because I have, of course, tried doing that with the hopes that it would actually work, but without the driver, it's probably not going to work.
So now what's connected on your Pi, Andrew? Alan, sorry.
Oh, sure. Yeah. So I have the BME 680, which is a nice sensor for temperature, pressure, humidity, gas content. And it looks like everything is working here. So let's go back, scroll down to the latest. So we can see that the sensor is pushing data out, and I believe the dashboard has found our field. So you see, we didn't configure anything.
No.
So let's see what we have here. Hopefully we have what we need. We're gonna see what this sensor, yes. So we didn't do anything, as you saw, but already we have graphing of, I'm gonna make this 5 minutes so it looks a little nicer.
24,000 degrees. Are you on the surface of the sun?
Well, look at the humidity and pressure are kind of high too. Yeah, we're going to talk about this. So, so why do we have these weird values? That is because this IIO system provides raw data right out of the sensor. Like they don't do anything to the values that the sensor produces. So even the names, this one's called humidity relative, and this one's called temp. But that's not always descriptive. I mean, I guess this one is, but temp could mean different things. And this raw value, it's difficult to know what that is. I can tell you, you have to look in the README of the sensor to really see what you're getting. This is actually the temperature in Celsius as an integer with the decimal part. So it's really 24.49 degrees Celsius. But we've accounted for that in this particular block. If you look at the data part, first thing I want to say is it all comes out as JSON. You can change the format of the JSON that it provides. We're not going to do that, but what is interesting is this raw values service variable. If we change the raw value to 0, it will transform the values into something more human readable. So let's just go ahead and do that right now. So
not blackbird, falling bird.
Yeah, hold on. Which bird are we talking about?
I'm getting my birds confused.
Yes.
Falling bird. We're going to, in the we want to do it in the sensor block. We're going to put raw values, and we're going to set it to 0 to turn off the raw values. And then the sensor block will restart from that. And once it restarts, it should start transforming the values that it gets from the sensor into something more readable. And if you're using this and you want to change how it transforms those values, like we put in some of our opinionated ideas, you could change the code in this Python. It's pretty easy to read. And for each device that's supported, we have a list of what it's making the raw values into something more
280,
useful.
280, HTU21. Yeah, I can see the device types.
I won't go into
sensor types.
Yeah, I mean, I won't go into the code, but I believe that it has updated. So let's go back to this and see if we have the new fields. Let's see, I think we might have to do a refresh. Yep. So here are new fields that it has found and automatically added to our dashboard.
So now we have temp.
Right. We had temp with this crazy value.
Temperature.
Now, if we go to temperature, we have a beautiful Celsius value here that makes a lot more sense. So it's obviously done some rounding, but it's a lot easier to understand than temp 24540. It's also smoothed out this humidity from humidity relative. So if any sensors that you're using, it will also change whatever they're calling humidity. If it finds humidity in the name, it'll just change it to humidity to keep them all consistent. So that's that. And then the one other thing we can do, we have a service variable for changing this to, or all the temperatures to Fahrenheit, if that's what you'd like. I won't do that now because that's pretty self-explanatory. Yep. But there is something else that I did want to show this, but there's more to this.
There's more? There's more
to this.
How much more can there possibly be?
Mark, if you could switch me back to the the desk.
Sure.
Yeah, we can do that, Mark. Yep, got it.
Okay. So you saw that I had this 4-way connector. Well, let's just.
Yeah, you're wasting two connectors.
Don't even tell me you're hot plugging this.
I'm just going to hot plug in.
No.
This is the VEML 6070.
The what?
The EML 607L.
Hang on, let me grab that.
I believe it's
okay. VEML 6070 UV sensor. I will put that into comments, and let's also get the URL for that.
So I just added it onto this bus, if you will, and I'm putting it as close to the window as I can because it's a UV sensor.
UV sensor, okay.
So we don't have that level of auto discovery on here just yet, but the only simple thing you have to do is just kind of bump the sensor container and let it restart. When it restarts, you should see it down here, detect this new sensor and start publishing that data for it as well. So we like to call this really, no fuss, because normally you'd have to figure out what kind of driver,
Okay, now wait a minute. Two things. First of all, you hot plugged that.
I did.
So I don't understand under the hood, but the kernel simply detected it at its address. Now, do you have to configure the I2C address, or that's done automatic?
It's automatically in here. For all the sensors that we support, we already know what the I2C addresses are. The only time that would be an issue, again, is if you had two sensors that were trying to use the same I2C.
Address, right.
You would just have to fix that with probably a hardware setting. But let's go back into our, like I said, we didn't do anything other than restart that container. And if we scroll down here, we may have to
refresh
this screen.
Grafana has to pick it up.
Oh, look at this. We have two new values here.
What?
UV intensity and UV index, which is 0. There's very little UV in here. My windows basically filter out most of the UV. So it's just showing light intensity, but the UV itself is probably going to be pretty low inside here. But again, all we did was just drop another sensor on, just refresh a few things, and it just picks up. Didn't have to think about drivers or addresses or anything like that.
So Nico, is mentioning that. So when every time that it's starting, the sensor container, it does the I2C detect, the start of the container, and figures out all the addresses of the sensors that are connected to the device, right?
Yeah, it's a combination of some like custom Python code and I2C detect, because I found that I2C detect alone couldn't find everything, and the Python code I was using could not find everything. So I kind of used both to make sure I found everything. Then we unload everything it finds and reload it. That's basically what the sensor block is doing. And then it starts an HTTP server or an MQTT server and publishes the data. If we look really quickly back here, this is the main part of this is the sensor.py. And again, all this is up there. So if you could adapt this to whatever.
Put that back on real quick. It is just sitting at /balenaBlocks/sensor.
Yep, and that code that we refer to is in the iDetect part, where it looks at all of the devices and decides which one to connect to. So that is the sensor block in a nutshell. Obviously, a lot more you could do with this.
Yeah, sure.
You could push it to. But really quickly, in the time we have left, I wanted to show the other block that we also introduced, called the pulse block. And I guess the question is, what is a pulse? I had this great graphic, but I don't have it, so I'm just going to draw it just real quick.
Artwork? Hold on, wait a minute. We got to get the camera. Hold on a minute.
Yeah, wait a second.
I need a better pen.
Wait.
There's my pulse.
Okay, a pulse.
Let me just annotate that real quick. Hold on. So,
which is not to be confused with, so 0 volts or 3 volts. Okay. Not to be confused with like a sine wave. It is.
It's a square wave.
Yes.
You could call this a pulse width modulation.
Okay.
But basically, you have a lot of different equipment that outputs a signal like this that alternates between 0 and 3 volts. And it's based on some kind of action. It's counting something or whatever it is. You want to know how many of these pulses are generated per second, per minute, to count different things. So we've created a block that does just that. It counts pulses. And what I've done is also created this little device here.
Oh, wait a minute. What is this?
What's that?
I added this little device that is just a display for the pulse block. So you can connect the pulse block just like we did to the dashboard, to the connector. It outputs the same format of JSON as the sensor block. But in this case, it's also going to this LED display. This is also available in the Balena Playground. So if you want to build this little display, you can. This button here just lets you scroll through the different indexes in the JSON. So now 01, the output of 01 is actually the pin this is coming in on. This is pin 37.
Chat as well.
And if you have 3, 4, you can just go through all the different values in the JSON. Actually, 00 is the UUID of the device. Oops, and I keep going past it. So there we go. So that's I'll show the UUID, which is 8851, at least the beginning of it. But let's do a quick real world example. So what would you want to use this pulse counter to count pulses? Well, here's something that generates pulses. You may have remembered this from Chris's happy hour, where he did that gorgeous Geiger counter. So this is the the guts of a Geiger counter without all the really nice stuff that Chris made. So I'm just going to attach it. It has a pulse output. I've color coded these so I can do it really fast, but we're going to connect ground. It's really just 3 wires. Ground, the output pulse, which will connect to one of the GPIO pins, and power. And when we hit this, the power on this should start up, and it should start counting pulses. The one thing that I need to do to get this to work is I just have to go into the pulse block.
Wait a sec.
Oh, yep. Hang on.
Yeah,
I need to go in here, and for the pulse, there's a lot of different service variables which you can see in the repo. But for this one, I need to.
Do you have the correct bird? Are we on the correct? Yeah, this is Blackbird.
So.
Okay.
Yeah. So a big thing about pulses is how you're how are you accounting for the noise that can be generated by a pulse? And normally, if you're using a mechanical switch to create your pulses, just on-off switch, which you could use to create pulses, they tend to be very noisy. So you want to invoke the pull up or pull down resistors in the GPIO pin. But since the output of the Geiger counter is very clean, we're going to just delete this pull up, pull down. And that's all mentioned in the repo. So as soon as the pulse block resets, we will then look at the values that are produced from the Geiger counter.
So basically it's the same. It's the pulse connector InfluxDB going to the dashboard, or?
Yeah, if we...
Because we didn't build the...
We didn't build this one.
Yeah,
but
we didn't.
Really
just to tell to the people the workflow, yeah.
It's the same. It's the pulse. Instead of sensor, it's pulse going to connector, going to influx, going to dashboard, and then there's this extra container here to drive the LED display. And this container is available right now in the playground, and along with how to connect to the LED display.
Yeah, I put that into the comments as well for folks. Yep.
So let's see what the counter says here. Hold this up.
So let's grab that banner out of the way.
Are you doing that?
Yeah.
I think you can actually. You can see it.
Yeah.
You see it? Yeah, you can see it.
Yeah, you can see it. Let's just make.
We can scroll through the values. So 00 is the UUID. Let's see. Is this 1? That's the GPIO pin. Not very interesting. 2 is pulse per second. Let's see. Get our data. Here we go. So this is the number of pulses per second, I believe. Mm-hmm. You really just have to know what data is coming out. We can look at the JSON to see that, but I kind of know it by heart. And you probably know what your data is if you do that. So 5, 6, I believe, is pulses. Pulses per minute is what we're really interested in, because that's how you measure radiation. But there's another thing that you can do. Let me see, it's 0. Oh, I wrote it down here. Hold on. We want number 7 is what we're really interested in here. So here's 7.
0, that's good.
3, 4, 5, 6, 7. Okay. 20. Okay. So that's 20 pulses per second, 19 pulses per second.
Yeah.
That is one measurement. I'm sorry, pulses per minute. It's pulses per minute is a standard Geiger counter reading. And by the way, I'm no Geiger counter expert, but that's
Chris is, though.
Yeah, Chris is. But before we go any further, I just want to make one modification to this, but just showed we built a Geiger counter out of blocks here. We didn't write any Geiger counter code. We just put a bunch of blocks together, and we have a Geiger counter here. In fact, if we go to the URL.
The Geiger counter itself, you plugged in, we saw that, and running on that little chassis you have there is what, a Pi behind it?
Yeah, it's a Pi.
Yeah, it's a Pi 3. Yeah.
So we now have a Geiger counter that's charted. It's on a public URL. You could share this Geiger counter with people. You could see it over time. It's not showing much because I just connected the Geiger counter. But as these numbers change, you could watch over time. And the great thing is you could see some very long periods. You know, the Geiger counter information, I think, is more helpful over very long periods of time. Small changes aren't really helpful. But here's pulse per minute. This block also supports something called pulse per minute multiplier. Now, right now, they're basically the same because the default multiplier is 1. But if you're really into Geiger counters, you want to also know, in addition to pulses per minute, you want to know microsieverts per minute. So to get that, all you would need to do is multiply this by a factor. So the block supports taking a value, your pulse value, and multiplying it. So all we're going to do here is go into pulse, and we're just going to call it, it is pulse multiplier. Pulse multiplier. And for a Geiger counter, for every click, it's 0.00812 clicks per microsievert. So let's add that in.
What?
So we'll restart. And once it restarts, that ppm mult value will now be microsievert. So again, without having to know, the pulse block doesn't know it's a Geiger counter, but giving you the possibility to create that value. Now this should drop way down because it's a fraction of a click.
I see it in the repo that you've documented this, so that's perfect.
That's in there. So we'll give it a few seconds.
Copy paste.
Sure that it is doing that.
Into the comments, so there's the value.
So let's just refresh. And so now we have pulse per minute is still the clicks. It's dropped way down because the container restarted, so it takes a minute or two for it to get back up. But now it's counting. Now in the pulse per minute, we're getting the number of clicks, but in ppm mult, because we added that factor, we're getting microsieverts per hour. So USVH, right? So
so my question is that high or is that low? Should you be concerned? What would be, I mean, that's just an ambient sort of background radiation. Now, do you have any radioactive material? I won't ask where you acquired it.
I'm not going to. You should ask. That's why I went to grab these bad boys.
Oh no! Where did you go? Oh no! Hold on. Make switch the Oh no! What is that?
The number's going way up. 0.6.
0.9.
This is really dangerous stuff. We're at 1.3 microsieverts. I think at 2 you're supposed to evacuate or something.
You're getting dangerously close. I don't know what that. You better back off. Yeah.
Is it available on eBay to anybody of any?
No, we're not sharing any links or URLs. I don't know where that came from or what that is, but wow, super cool.
That's lovely. Do we have time for one more quick?
We're at the top of the hour. But yeah, I mean, if it's a couple of minutes, by all means, we can certainly go over. Folks that need to drop, obviously, feel free. You can always come back and watch it later when it's on YouTube.
Absolutely. I just wanted to add in another use for this pulse counter, which makes it really, what's the word? It makes it versatile. Excuse me. It makes it much more versatile. So I'll do this in 4 minutes. I understand if people have to go. We'll keep it really fast. So I'm going to disconnect the pulse counter actually first. Let's just disconnect it. Get that out of here. We don't need this. I'm just going to toss it. Do what Katil did. I'm just going to throw it across the room.
No. We might need that in the future. Don't break that. And meanwhile, your radiation is up to 9 point something. You might need to evacuate.
12.
12. Oh my
That's
God.
uranium or
go back to
no, but
this
that's
view.
because the Geiger counter is not connected.
Yeah.
So
All right. What is this contraption?
this is, it looks like something to hypnotize people with, but that's not what it is.
Yeah, it does. Yes.
This is actually taken from the what you would see on some jet engines use these spinners. If I spin this, you might have seen this in the airport when you're looking at a jet. It's to show that it's moving. That's not really to hypnotize people. It works at various speeds. Let's see. I think my batteries are getting low here, but the reason that I did this is so that you can see on the back by getting close. You see that slotted wheel right there?
The little black. Yes.
There's a slotted wheel with a photo interrupter attached to it right
Okay,
there.
the black wire that's leading up to a rectangular black unit. Yes.
Right. So that's creating a pulse because every time one of those slots passes through the light beam, you can see right there, it's going to create a pulse. So if we connect this up, and I'll do it.
Wait a sec, I change the cameras.
I'm going to connect the pulse to this, and we will basically, without changing.
I need to buy cables for of different colors.
Yeah. Don't. Yeah, be careful.
If I mix up the colors, I'll short the whole thing out, but I think I got it.
Well, and will it short you out?
So now let's run it, and without changing any software, really, we just now have a pulse counter. We have a tachometer, basically. So if I go to, let's see, actually, it might be better if we just go back to the screen because it's still on the,
There we go.
So pulse per minute, pulse per second. So here, we're going at 59. It's saying 59 revolutions per minute, but it's really not that fast because that slot has 20 slots in it. So it takes 20 pulses for one revolution.
For a revolution, yeah.
So all we would do is go into the service variable and change this to 1/20th, and which is 0.05. Now we're getting, we go back here.
Now, wait a minute. You didn't restart the container on this.
I didn't restart the
You
container.
plugged in a new sensor.
Because they have the
You
same
plugged
cable.
in a new sensor.
I did. You could do that. The only problem is that the Geiger counter data is going to be this part of the graph, and then RPM data. But the idea is that you could switch it. I could have restarted the pulse container to zero it out, but now if we look at the pulse per minute, and if we let's see, ppm molt, now we're getting RPM. This is revolutions per minute now because we're dividing by 20. So every 20, if I have the slot here. So
and I can even see it.
It's 20 slots per revolution, so we had to divide by 20.
Yeah, you can see it's rotating a little bit faster than once per second. Yeah. So
let's speed it up here. Let's make it, or actually, I think that's the fastest. I just slowed it down, so now it should be running at about half that. But it should take a minute to go down. So that is, if you look at this, that's the pulses per second. That's how many times it rotates in a second. So that's pretty much it. Those are the blocks.
Incredible. I'm in shock. The quantity of discrete projects, functionalities that you showed off is insane. including the fact that you're hot plugging all of that.
Yes.
And yeah, wow. So I don't see any questions that have come in the past little bit here. Let's see.
Yeah, I don't remember any.
I'm glancing, I'm scrolling back up. I don't see any other questions, which means you just did a fantastic job of explaining it all.
Hopefully.
Yeah.
But there's a lot more information in all the repos that
Yeah.
we've shared. Pretty much everything I said and a lot more.
Yeah.
And Alan, these blogs are available on balenaHub, right? So if people go to balenaHub
Sure.
and click on blogs,
Yeah.
they will get quicker access to them, right?
Yeah, absolutely.
Copy paste did not work, so I'll put them in individually.
So if people go here on Hub, balena.io box,
Yep, then we'll
you can find the new ones.
That for the pulse and for the LED. All right, Mark. Well, anything else? I mean, obviously, besides a gigantic thank you to Alan, any other?
Adishit is mentioning about a new application that there is on the balenaHub, that it's mixing. It's using edge impulse machine learning model with X-rays to detect the type of pneumonias based on this big database of X-rays that Adishit made with edge impulse. So go and check that project because it's pretty interesting. Disclaimer: this is not a medical application. It's just
very cool.
Yeah.
It was able to build the project, but by all means, it's theoretical in nature. In that, we are not doctors, so
exactly.
Just you can use it for learning and research purposes. But other than that, I think
that was a blast. It was amazing.
That was fun. Thank you. Thanks.
Just to remember to people that we are hiring, right? We open a new position for Balena Etcher. So if you love Etcher, maybe it's a great opportunity for you to apply.
Come join
Balena.
the team.
And what else? We are also hiring security engineer.
Go ahead.
Sorry, front-end engineer.
Go ahead.
And next week, all yours.
Yeah, next week I'll show off how to add Datadog, some telemetry for your IoT devices to your projects. We've talked about blockifying that one in order to be able to just pull it in to your projects. But for the moment, as it stands, it's a separate, what we call a sidecar container. And it's still very useful to get some device health, device diagnostics for your fleet. So it's good from, in an enterprise fleet standpoint when you've got thousands of devices out there and you need to check on individual health. You can drill into the data that way. So we'll give that a look next week.
Yeah. We will have a nice demo next week. So that was the 47th episode. Thanks for coming and see you next week.
All right. Bye, everyone.
So
Bye.